Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on Thevenin's theorem. So this is going to be a third video in Thevenin's theorem, where in previous videos I've already explained what is Thevenin's theorem, what are the procedures to solve the Thevenin's theorem, and then I have solved many problems in Thevenin's theorem. I would recommend you people to go through those videos first and come back to this video so that you can easily understand this particular video. Right? Today we will see more problems on Thevenin's theorem. And before that, I would like to refresh the procedures again. The very first step you have to do is we have to draw a Thevenin equivalent circuit. And this next step, what we have to do is we need to find out VTH. How will you find out VTH? You will remove the load resistance and you will find out VTH. And the next step is you need to find out RTH. How will you find out RTH? You will remove the load resistance and also you have to remove the source, right? Killing the source in the sense, if it is voltage source, you have to do short circuit, and if it is current source, you have to do open circuit. And then we have to find out the IL value after substituting the values of VTH and RTH in Thevenin equivalent circuit. Correct? So now we will directly go to the problems. I've already solved many problems, so I'll just explain those problems here. Right? So if you want step by step solving of a problem, you just go through the previous video so that you can clearly understand how we have solved the problem step by step, right? So very first step, what we have to do, the question given here is calculate the current through the load resistance. So here the load resistance is 50 ohm, right? So what you will do is here we have to draw the equivalent circuit, right? Where we will consider VTH, RTH, and this will be 5 ohm, sorry, 5 ohm, right? 5 ohm is the load resistance. Now, next step, what we need to find out, we have to find out the VTH. How will you find out VTH? You have to remove this particular load resistance. If you remove the load resistance, how it will be? The circuit will be like this, correct? The circuit will be like this. You'll have this 4 ohm resistor, you'll have this resistor, and you'll have this particular resistor, and you'll have this 10 ohm resistor, right? And you'll have this open, correct? This will be 4 ohm, this will be 4 ohm, this will be 8 ohm, and this will be 10 ohm, right? And you'll have 20 volt, right? And now you will solve. You will solve here. You will use mesh analysis and you will solve the problem. Correct? You will find out the voltage across this particular terminal A and B. And then next step, you need to find out RTH. How will you find out RTH? The same circuit. Now, what you have to do, you have to remove RL and as well as the this particular voltage source as well. So the circuit will become like this. Correct? The circuit will become like this. It will become like this, and you'll have to approach the circuit from this end. Right? So this will be 4 ohm, this will be 8 ohm, this will be 4 ohm, and this will be 10 ohm. Right? And when you approach the circuit from this end, right, then you have to solve one by one. Right? This will be parallel, right? And again that will become series with this, right? And then these two will become parallel. Right? Like that, you have to solve and you need to find out RTH. And finally, you have to substitute the values of VTH, RTH, and then you need to find out the value of IL. That is how we solve the problem, correct? Now we'll see step by step. So find out VTH, I have removed the RL, right? And now what I have done is I'm using matrix method. You know matrix method, how will you solve? It is R11, R12, R21, and R22. Whereas this will be always minus because of diagonal elements. Correct? So you can see here this will be total resistance 8 and this is common resistance 4, that is minus 4, and the second loop it is R22, so it is the total resistance here 8, 4, 12 and 22, right? So we need to find out the current flowing across this particular resistor. So we take I2 current alone. So the voltage here is 5 volt, right? That is 5 volt. And now we need to find out RTH, same circuit again. This circuit will not only remove RL, we also short circuit this particular voltage source. So if you remove the voltage source, now what happens? This becomes parallel connection, correct? And if you solve, it will become 2 ohm, right? And now what happens? This becomes series 8 plus 2 10. And again, now what will happen? It will be 2 10 ohm resistor. It will be 2 10 ohm resistor across AB. This is 10 ohm and this is 10 ohm. And if you find parallel connection of it, we will find out the RTH as 5. And now we have find out what is RTH, what is VTH. If we substitute the value, we can able to find out IL, right? So this is the same steps we have followed in previous problems as well. Right now we will see another problem which is a bit complex problem where you can see the question is to find out the Thevenin across this particular resistor, 5 ohm resistor, right? And now when you remove this particular resistor, the circuit will become a star connection. So we have to find out this parallel connection, like that, right? So we'll see step by step. The very first step is we have to draw the Thevenin equivalent circuit, where I have drawn this Thevenin equivalent circuit VTH, RTH, and 5 ohm, right? And then finding out VTH, we have to remove the load resistance. The load resistance is removed. If the load resistance is removed, we consider this as series, these two as series, right? So 16 and 23. Now this will become parallel, right? So if it becomes parallel, now circuit this becomes like this. We find out the current, that is current is equal to I is equal to V by R. 100 divided by 9.44, you will get this value 10.6, right? But we need to find, this is different branches, so we need to find out the branch across this particular current and this particular current, branch current across this branch and this branch. So now what we can do is, if it is 100 divided by 16, we will obtain the current across this particular resistor, particular branch. Similarly, if it is 100 divided by 23, we obtain the branch across this. Why we are doing it? Because we need to find out the voltage across this terminal, across this terminal. So it will be, if we take this one, VAB, it's nothing but VAO and VOB, right? So we have already obtained this current, the current across this particular branches, which is 6.25 into 6, and this branch across 4.2, 4.35, 4.35 into 8. Right, so if you solve VOA minus VBA, we obtain the VAB voltage, which is 2.7, which is nothing but your Thevenin voltage, right? And from this Thevenin voltage, you need to find out RTH. So RTH, how will you find out? Once again, you have to remove the load resistance. I have removed the load resistance and the source as well. And as I said, these two, right now what happens here? There is no source. Now these two becomes parallel and these two becomes parallel, right? And if you solve this parallel connection, you will obtain RAB is equal to 8.97. This will become parallel, this will become parallel, and then we have to add these two, right? And now we have find out what is VTH and what is RTH, and we can able to find out IL, which is nothing but IL is equal to VTH divided by RTH, correct? So it is 0.19 ampere, right? So the procedure is same. First step, you have to find out the Thevenin equivalent circuit, and the next you have to find out the VTH and then RTH, and substitute the values of VTH and RTH to find out the IL, right? So today what we have seen is we have seen problems on Thevenin's theorem. I believe this video will be useful for you. Thank you, my dear students.